Hey guys, welcome to Great Learning. Cloud computing is a domain that has one of the best future trends in the world of information technology today. There are several reasons as to why this is the case, as to why this domain is trending to a level of popularity, and among those many reasons, one of the most important one is the fact that it provides so many cloud deployment models that gives developers this unparalleled access of actually having customization on the cloud platform, right? Now, these service models are key in helping us solve a variety of problems, and hence it makes it extremely important for all of you all to understand these models to a good amount of depth. Now, keeping exactly this in mind, we here at Great Learning have come up with this course on infrastructure as a service, also called as IaaS. Right? With that, I know you guys are super excited to get started with this course. Well, what are we waiting for? My name is Anirudh Rao. Let's get started.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.
Alright guys, so to come to the agenda to discuss the IaaS in cloud computing course we have for you guys today, we're going to start out by actually taking a look at understanding the domain of cloud computing, right? So we're going to begin by having an introduction to cloud computing to ensure that on the fundamental level we have things cleared in terms of understanding what the technology is and a lot more, right? Now, after you understand what cloud computing is, you'll be very curious to take a look at the various types of cloud deployment we have in today's world. Now, if you're wondering why cloud deployments are so important, you have to understand that with respect to cloud computing models, you can actually have various types of model deployments based on your various types of cloud applications, right? So we're going to be checking out that as well, and we're going to dive right into the heart of the topic, and we're going to be taking a look at the various cloud computing services we have, and we're going to be taking a look at having an introduction to what IaaS is. It stands for infrastructure as a service. We're going to take a look at that. We're going to be also understanding how this infrastructure as a service model works in general, and of course at the end of the day we're going to be also discussing the advantages, and there are some caveats or disadvantages to IaaS that we have to discuss as well. We can actually get started with what is cloud computing. Now, whenever you think about cloud computing, the most important thing that would come into your mind, the first thing that would pop up in your head is probably something, an operation as simple as backing up your photos to your Google Drive or something like that, right? Back in the day when cloud computing started out, this was actually the case. When users started using it, when it was started to put to commercial purposes, at the end of the day, it gave very little room, very little freedom for what the end user could do. But today, if you take a look at cloud computing, you can back up your photos, you can have entire companies run, Fortune 500 companies and companies worth trillions of dollars. You can have the infrastructure, the entire setup on cloud computing platforms, and run your companies directly from there, right? So what is cloud computing if it's this powerful? Well, cloud computing is basically a concept of wherein you will have servers, you will have a lot of physical infrastructure all around the world through which you provide services, right? Now, when I say services, you might have heard of this concept wherein you might be backing up a couple of things to your office server, right? Your office server is nothing but an entity that is sitting on premise, that is sitting right next to you in the server room in the same building, same city or something like that, right? In the case of cloud computing, what happens is that there are servers similar to that, but it is exponentially more powerful and can handle way more number of clients, and it is strategically located everywhere around the world, such that when someone in the US has a requirement, they have a server there to provide for that. Someone, let's just say in Egypt, has a requirement, they will have a server nearby there to make sure that they can have access to any sort of services, right? You can build and deploy machine learning algorithms. You can have a variety variety of storage, you can perform real-time computational analysis, and you can do a lot more with today's world of cloud computing, right? Back then, it was just backing things up. It was just ensuring that you were using a server to basically have an extra point of storage, a redundancy in case something fails. But today, having an on-premise server is for that purpose, right? So having an on-premise server is meant as a backup while having your entire company work on the cloud platforms like AWS, Azure, or GCP is the trend. You would have seen this entire trend reverse, because what those guys are doing, the services, the tools, the techniques they're offering to their platforms at a very, very competitive price in today's world, what makes these companies actually go on to prefer that, right? So at the end of the day, our discussion should be, why should we even require cloud computing in today's world? The first thing you have to understand is that we generate a lot of data in today's world, right? Now, I just made that sound. I just snapped my fingers. By the time you actually heard the snap, we would have generated terabytes worth of data, hundreds and hundreds of terabytes worth of data by the second you heard that sound. Now, when the world is generating so much data, and the world has also realized that data is almost like fuel, right? You can use it and you can drive so many things with it. Back then, probably 15, 20 years back, when we generated a lot of data, it was archived and maybe it was destroyed later on. But these days, people realize that even something which might have a small impact on your business, if analyzed to a good amount of depth, has a profound impact, right? So considering that, data is transforming the way we work, and of course in today's world, the way we work with the data itself is transforming in a way where we're generating so much, right? So having the ability to move entire companies and work from the cloud, having access to their extremely fast data storage methodologies and super powerful processing machines are what will give you an edge over your competition, right? Think about it. And it's not just this. Back in the day, we were limited to the amount of services that you could access via these cloud computing platforms. But today, you can, I just want to say this, you can do almost everything, right? 99.9% of what you would do on an on-premise network, you can do it on the cloud. Sometimes it is considered to be even more safer, even more robust, and at the end of the day, the rate at which it might fail or it might cause issues is coming down with every single day, right? But the biggest advantage of why people are considering cloud computing, to be very honest with you, is the last point there. The pay-as-you-go policies, right? Now, pay-as-you-go is a concept as in you will only pay for what it is that you're using. Let's just say you have a requirement wherein you require a virtual machine for 20 minutes to operate on a certain load, right? You have a load and you want to use it for 20 minutes. Now, let's just say you don't have any hardware at your home or your office. What would you do in this case? You would go to your shop, you would purchase all the hardware, get it all set up, find a person to install everything for you, all the software, and eventually find a person to maintain all of that as well, right? But with cloud computing, it's a few clicks of your mouse, and guess what? The initial investment that you have made for an entire computer, which you'll probably need only for 20 minutes, and later it might just be used for something else. But in the case of cloud computing, you're only allocated that computer for that amount of time, and you only get to pay for that much, right? That is a fraction of the cost of what it would actually cost to buy an entire computer. Now, similarly, just enlarge this idea 1,000 times or 1,000,000 times, and you would understand how much money you would actually save doing this. It's not just money, it's a lot of headache running a lot of servers, because at the end of the day, it's not just buying these servers, it's about maintaining them. It's servers, right? It will tend to go bad. It'll have a lot of hard disks, and hard disks go corrupt every now and then. And it's not just that, you'll be paying electricity bills. You have to make sure it's compliant with your fire hazard standards, and at the end of the day, you have to also cool it enough such that it doesn't melt or it doesn't burn up or something like that, right? So all of this headache will eventually cost the company more time and more money. But if you can offload all of this to say, hey, I want someone else to take care of this, I don't want to be bothered by any of these, I want to spend my time, I want to spend my vital time actually working on my application. That is important, and that is one of the reasons why cloud computing is so popular in today's world, right? Now, after that, you might be asking a question saying, hey, Anirudh, okay, that's fantastic, but how does this domain work? How does the domain of cloud computing actually work? Now, when you take a look at understanding cloud computing, you'll have to basically divide it into two divisions, all right? One is the front end, the other one is the back end. Now, when we say front end and back end, right now, wherever you're watching this video, you basically are looking at the front end side of things, right? Front end is where you have a user interface through which you can directly access a video that is stored again in a server, which can be right next to you or which can be thousands and thousands of miles away from you, right? But it is giving you a feel as though you've plugged in a USB into your computer right now when you're watching the video, right? But it's only the front end that is making sure that you have this user experience while the actual data gets stored elsewhere, and all the things that is needed for the communication between your front end and back end is also important and present, right? So front end is such an important concept for cloud computing because at the end of the day, user experience is what matters a lot for all of us, even in the most mundane tasks that we do, right? Think about social media. Way back in the day when Facebook came out, when its first version went viral, went public, and everyone was switching from Orkut to Facebook, you would realize that it was nothing fancy. It was amazing. It was going good. But compare that interface to today's Facebook interface, right? A million things have changed. Of course, some of you can argue that a couple of things were better then, a couple of things are better now. All of that is a separate discussion. But the user experience you get even from social media applications will want you to spend more time there. It will want you to explore a lot more. Cloud computing is very critical in this aspect because you will have a variety of developers, variety of users, clients, everyone who may or may not have used a cloud computing platform ever in their lives before, right? So considering everything, the goal of a cloud computing platform is to ensure you have a great front end, not only to use the platform, but at the end of the day, when you are creating applications and deploying them on the platforms, those also get to have very good front ends, right? So front end, regardless of where it is, web development, data science, cloud computing, no matter what domain you look at, one thing you have to understand is that it is super critical. Coming to the backend is where again all your data is stored. It is literally like the heart of heart of cloud computing, wherein everything that's necessary for it to work is right there, right? So let's quickly explore front end and back end a little. As I just told you, front end is what actually helps the users have access to all the data that gets stored, right? Now the data is stored in the back end. The actual data is in the back end, but it gives you a feel as though you're directly connected to the back end. In many cases, you directly are, right? The front end does not just give you a user interface, but it has a direct impact on your user experience as well. So understanding that what you see is not exactly how a server would work. A server would work, it'll take a lot of programming, a lot of database knowledge and everything to get it run and set up and all of that. But at the end of the day, you wouldn't want everyone to do that, right? If you just have a backend running, separate all the complex procedures, give the user a good front end to work with, that is a win-win situation. Think about it. Right? Now, when that is done, the next thing that comes into the picture is the actual backend. Backend, as I just told you, is where all the data gets stored, where all the servers are there, where everything needed to run these servers, power, cooling, whatever it is, right? So the backend is literally, you might have seen videos of these data centers and all of that, right? And if you haven't, I really suggest you head to YouTube and check them out. All these giants such as Google, Amazon, even Facebook for that matter, all these guys who generate a lot of data and have to handle a lot of data, they have data centers which have so much security, and you will understand the amount of care that goes in while you actually take your data to a provider and say, hey, I want to take I want to store my data in your platform or something like that, right? So if there's this very simple operation of you actually analyzing data to create some beautiful looking graphs or something, a beautiful division between the front end and back end is basically you actually showing the graph is on the front end, right? Maybe you're in a meeting, you just want to show the graph and say, hey, these are the data points I used to get to this graph. That is the front end. But all the data that is required, all the analysis that goes into the data and the actual creation of the graph, where do you think all of this happens, right? So all of this happens in the back end, and it is very important for you to analyze this. Okay, that's good. So we discussed the front end, we discussed the back end, but how do you get the front end and the back end to talk? Is it as simple as just running a couple of wires or something? Not really. So basically we have a software, in fact we have multiple softwares called as middlewares. Now middleware is nothing but a platform that acts as a bridge between two or more applications or two or more devices, right? Now, whenever you are using the front end to connect to the back end, again, as I just told you, it's not a simple connect of a wire or something. This sits as a bridge to ensure that at the end of the day, you have one server wherein you can have multiple clients connect to it, in fact, at the same time, right? That's how the world works. So this software, which acts as that bridge, this software, which acts as a connector through which you can have access to these servers, services, or anything as such, is very important for you to understand. Getting your front end vitally to talk to the back end, and any request that is basically made by your front end, when your front end says, hey, the user clicked this button, now I want that task to happen, your front end will tell that to the back end. Your back end is like, okay, if that's a valid task, I'll do it for you and I'll show you the result on the front end again, right? These operations, now a very simple click of you guys entering your email ID, password, and hitting login button, maybe on your Gmail or something, right? When you hit login, it's a front end application that you're basically trying to use, but as soon as you log in, it has to go to the servers, check if your username is correct, check if you've entered your correct password and all of that, and eventually come back to tell you if everything was correct. And if everything was correct, you log in. If everything wasn't, you don't get to log in, right? So that is something which is important for you guys to understand. After we've discussed all of this, you'll be very curious to understand what are some of the types of cloud deployments that we have in today's world. Well, to answer the question, we have four very important types of cloud deployment today. It's the public cloud, the private cloud, the hybrid cloud, and the community cloud. Now, even without, presuming that you might have never had any experience with cloud computing, as soon as you take a look at that, don't you think you can guess what it might do, what a public cloud is, what a private cloud is, what a hybrid cloud is or something? Just think of your favorite cafe or something, right? If someone says, hey, this is a public cafe, it means that anyone can walk in, anyone can have a have a coffee there and walk out. But if someone says, hey, this is a cafe, but it's only private, it's only meant for the employees of this particular building or tower or something like that, there you must have some sort of access or authorization to actually get into that, right? Similarly, the cloud works there as well. But when you say hybrid, people say that, hey, so maybe not outsiders cannot walk into this particular cafe, but maybe the people who stay in these apartments can walk into this cafe and have a coffee and go, right? Think about that. That's hybrid, right? People outside maybe just one apartment building are still coming, and you have multiple apartment buildings where you're saying if you're part of this and this, you can actually, it almost seems like it's private, but when we actually explain the concept of hybrid, you'll have a better understanding. And then it's the community cloud, right? Let's actually get right into the heart of these to talk about what each of these mean, because in the context itself, I'm sure you will have a better idea of what they are, right? Now, to talk to you about public cloud is a super popular form of cloud deployment. Now, the infrastructure, right? Think about the examples on the lines of AWS, basically Amazon Web Services, Microsoft Azure, and even the Google Cloud Platform. These are public clouds. As in, if you can log into their platforms, anyone across the world can actually start using the features provided by this provider, right? The infrastructure is provided for all, and it can be shared among all the customers as well. So it doesn't mean that if there are 7 billion people using cloud computing, it doesn't mean that there are 7 billion servers out there. There could be just a handful of servers which have the capability to handle this huge amounts of load and all of that, right? So there can be cases where, in the case of public cloud, where there's a team who's working on software development, or there's a team developing a couple of projects which will require collaboration not just within the organization but maybe on the outside as well, right? So having public cloud again has its own advantages and disadvantages, but in today's world, having the access to say, hey, this is not a research topic, this is not something which is classified or something like that, right? People have access to it. You and me as absolute individuals can in fact launch an entire company if we want to on the cloud computing platform, and you have the facility to do that. You have to thank public clouds such as AWS, Azure, and GCP, and of course there's a lot of other people as well, but you have to thank them for this ability, right? So the biggest advantage of public cloud, in my opinion, is the fact that you have the pay as you go model. Regardless of any type of cloud, in my opinion, having the access to pay as you go model is something that's going to save a lot of effort, a lot of time, a lot of resources for the company, right? Think about it. Why should you have to pay for something in full, knowing very well that you might be only using it for a short amount of time? Think about the PC example that I gave you, right? Let's just say you're into video editing or something, you require a very powerful machine right now to use it, and you'll know that, hey, I'll only use it for 1 day, 1 week, or 1 month or something like that, and after that it's your heavy initial investment, and you'll know that I might not be able to use this anymore, right? Because maybe your project ended or something like that. In that case, what you would do is you would jump onto the cloud computing platform. They have a ton of, all these cloud computing platforms in today's world have a ton of like really lightning fast computers out there. Depending on what what level of speed you require, how many clients will access your application, what is the amount of resources you require, you can map each and every single thing and just pick up that and just pay for the amount that you would have used, right? If you've just use something for 1 hour or 2 hours or something, you would only pay for that. Now, with this comes another huge advantage. One, you're of course saving a ton of money, but the second thing you also have to look at is that you'll be creating highly scalable systems, right? Today, you have an application which 10 people are using. Tomorrow, it might grow to 100. Day after, it can be 1,000. And maybe 3 months from now, your company just went viral and there are millions of people flocking towards your brand. When that is the case, your servers, if it is probably in-house or on-premise or something like that, you would have to go out to buy new servers, upgrade all your network modules and all of that, because you wouldn't be able to handle that amount of traffic. But with respect to these platforms, you can never overwhelm these platforms, right? No matter how much traffic you bring in, the platform has more to offer, right? It's almost like an infinite funnel, and it will keep providing the resources that you would require. That is how big today's world of cloud computing is. But with respect to cloud computing, in terms of public cloud, you have to understand one thing is that if you are looking for complete control, end-to-end control of your product, your application, and your platform, it is not possible, because if you've deployed your company on AWS, if you've deployed an application on Azure or something, how Azure works, and there's a very good chance that one or two servers might go down there as well, right? So that control you will not have, and that is an important thing which you should know about. With that, we can discuss about the private cloud, because the private cloud, these have been in use for a really long time right now, because whenever you think about certain companies running their own servers, running their own farms through which they have a ton of servers, and people of that organization only access to those servers, right? So these are private clouds, and these have been used for a really long time, as you could guess right now, and they are used, let's just say, by only one organization, right? But of course, since it's connected to the internet, if you're an employee of so-and-so organization, you can sit at the end of the world, at the other end of the world basically, and still connect to it with your email ID, password, or any other authentication protocol that they have, right? With respect to a private cloud, one thing is that you're not sharing your resources with anyone else. With respect to public cloud, that happens, right? One server can be used by 3 or 4 companies out there. With respect to private cloud, it's only your employees, your officials who are using that, and it is completely owned by the company themselves, right? So you're responsible for just buying the infrastructure, maintaining it, ensuring it runs well, and at the end of the day, everything that is required to keep those servers up and running is at the company's end. Now, with this, there come certain advantages and there are certain disadvantages. The advantage is, of course, the fact that if you're a person who says, hey, my data, the security for my data is the highest priority. This data is, it's classified. I don't want anyone else apart from the people in my organization to see it, and I don't want to be sharing servers and storing this in public domain. In that case, you can actually have a private cloud setup wherein people only, with respect to your organization, will have access to that, right? And you can, inside the organization also, you can say, hey, people with L5 access, L4 access, level 4 basically, have access to this, and anyone below L4 will not have access, and they cannot work with these servers, right? So that is critical for you to understand. Outside the organization, you can block all traffic. Inside the organization, based on authentication, again, you can still do that. But One disadvantage here is for the fact that you lose that versatility that you have with respect to public cloud, right? And the most important thing you lose is the scalability factor. As I just told you, if you have on-premise servers and private clouds running, today you have 1,000 people, tomorrow you have 3 million people, your servers will crash because they were never meant to handle 3 million people. But if you initially spent out a ton of money to say, hey, I know I might get 3 million people, so let me just buy it all right now. Again, it would have cost you a huge amount of money to buy that, and at the end of the day, after 3 million, maybe you can hit 10 million as well, right? And the remaining traffic cannot be handled. There again, your scalability has taken a huge hit. With respect to public cloud, this problem is also solved. But if that extra security, if security is your number one priority and you say, I don't care about anything else, security is what I want, private cloud is something you should look forward to, right? Superb. With this, we can take a look at the hybrid cloud. Hybrid cloud is considered to be the latest standard in cloud computing. I'll tell you this, because hybrid cloud is nothing but a combination of public clouds and private clouds, right? Now, there are certain companies who will say, hey, we have certain information which we don't want to put on the public cloud. We will have our own private cloud sitting at our office where we'll have all of these extremely critical information bits which we won't share to the public cloud, which we will have across the organization. And we also want to make use of certain perks that you're providing as a public cloud platform, and maybe have a front end there, maybe try to do something wherein your server talks to those servers and all of that. So if a company comes with a requirement such as this, you can use a hybrid cloud wherein both your on-premise private cloud and the public cloud can work hand in hand, right? But with respect to private cloud, as you already know it, it cannot grow up to the demand. It cannot meet certain demands as much as a public platform would do. But what the advantage of hybrid cloud is that you can use all of these capabilities that public cloud is known for. Scalability is the most important thing, right? You can literally use that amount of scalability and say, hey, if there's any heavy lifting to do, and if I know that my private cloud cannot handle any of these, great, I'm going to just move all of these heavy lifting tasks to the public cloud. And again, with a couple of mouse buttons, you can have any sort of power, any sort of resources in your hand to solve whatever it is your application requires and be done with it. Correct? Does that make sense to you guys? Because hybrid cloud is considered as the future, and around you, almost any company that you can name will be using some sort of hybrid cloud. No one usually goes completely private, or no one usually goes completely public. And knowing that, hey, there are certain advantages of both the domains that I would want to use, why do you think people will pass up on an opportunity such as that, right? That's super important for you to know. Now that we took a look at hybrid cloud, what it is and what it does, I think it's high time we quickly take a look at some of its advantages and disadvantages, right? Now, scalability and security are something which differs the public cloud from a private cloud, and we bring those two together, right? You can have the scalability of a public cloud, you can have the security of a private cloud, and you can bring those two together. Now, when you're using the best of both worlds, you have to understand that you will actually end up saving way more money than having individual solutions at hand. Now, this differs from application to application, but in the general sense, as I just told you, you can use the best of both worlds, and you can find ways through which you will be saving money in both the ways. For example, in the case where scalability matters, you don't have to spend a ton of money for your private cloud. Just whatever heavy lifting, heavy resources are required, just move that to your public cloud, you're good to go. And any sort of data which you would never want to put it in a public domain, store that in your servers. Good deal, right? But one slight risk that happens in the case of hybrid clouds is, especially when you're moving data between your private cloud and your public cloud, there is a very slight risk that there can be data breaches, your data can be hacked, your data can be manipulated in many cases. It happens extremely rarely, but it has happened around the world. And if there is an advantage, always, if there is a huge advantage as much as this, it comes with a tiny cost. But of course, all the cloud computing platforms in today's world are doing everything that they can to make sure even this gap that exists between your private cloud and public cloud can be built. You can have walls built around your data. It's called firewalls, and you can eventually make sure that unless and until you're authorized to have access to that data, there is no way that you can have access to it, right? So that's really important for you to understand about hybrid cloud. Now that we're done with hybrid cloud, the next thing in discussion has to be community cloud. With respect to community cloud, you have to understand it's very, very important for collaborative applications, right? Now, let's just say that there are certain users who opt in for a community cloud and they say, hey, there are many, many companies working in, let's just say, the same industry, right? Maybe manufacturing industry, maybe e-commerce industry or something, where they would say, hey, most of us will want similar levels of performance. I know for a fact that most of us might want the exact security protocols, right, or something very similar too. In that case, you can have a community cloud where one cloud will cater to one industry where there are multiple competitors who are also working and sharing the servers and working there, right? Now, you might ask a question saying, hey, if community cloud is considered, isn't it considered completely public? In many cases, yes, but you can also have it to be managed privately as well. You can have your own server there coordinating with the community cloud to make sure that at the end of the day, again, your data security, your breaches, all of that is taken care of, right? Now, in today's world, community cloud is extremely popular for government agencies. Think about banks and healthcare organizations, right? Now, all of these banks will have similar kind of security authentication. You might have realized you'll have a username, you'll have a password, you'll have an OTP, you'll have to enter a secret password, passcode, identification, something like that, right? So all of these implementation can be done in one community cloud and eventually everyone can start using that, right? Now, you might say, hey, that isn't very secure, but you'll be surprised at how effective it is. But again, it comes with its own advantages and disadvantages. The advantages is for a fact that all of these things that we say, hey, all these companies use the same authentication protocol, so let's just have one thing, right? So it's not just one random thing that's put into place. It's something which is usually compliant with an industry requirement that says, hey, this has to have the capability to do this. Only then will I and my competitor actually try to use it, right? That's one advantage. The second advantage is that it provides a ton of flexibility, heavy amounts of flexibility through which individual companies can get access to all these controls. They can work with it as they desire, right? But every advantage has a slight disadvantage, and in the case of community cloud, it portrays itself as a bottleneck through which you have one server. Let's just say hypothetically you have one server shared by two companies or something like that, right? So the bandwidth of how much you can load up the server and how much you can store data and move things around will be limited because it's one resource being shared with like two companies, right? Now I'm giving you a hypothetical example, but this happens in the real world on the stage as well, because at the end of the day, if you have something and you're sharing it, you don't get to use the full beans. You don't get to give it full throttle and use it all the time as you wish, because that resource is also shared to someone else, right? So you will have a hard limit that says, hey, your bandwidth is only this much. You can only store this much data. And again, think about scalability a little bit here as well, right? So that is where having a hybrid model is advantageous over community cloud. But as I told you, community cloud in many cases is way cheaper than private cloud, and compared to public cloud, it is cheap as well, right? So if cost is your primary concern, I would highly suggest you guys take a look at the community cloud. Now we're going to take a look at cloud computing services. I know you guys are excited to go about learning about these varieties of services and models that we have for you guys, and you have to understand that there are three very, very important cloud computing services in today's world, right? Type of models basically. We have three things. It's infrastructure as a service, platform as a service, and software as a service. So let's quickly take a look at what each of these are. But before we dive right into one of those to say, hey, this is what this does, let's actually understand the process of how you would go on to choose one of these, right? Now, your first thing should be is to thoroughly understand what platform as a service is, what infrastructure as a service is, and what software as a service is. After you understand the model, you're going to have some project which says, hey, I have these and these requirements and I want those requirements to be met. Then you compare those project requirements. Once you've understood the model, you can directly match saying, hey, PaaS gives me these many advantages, IaaS gives me these many advantages, SaaS gives me these advantages. So once you know what does what, and once you have a mapping, you can actually jump and say, hey, so I can start setting up my workflows based on which model I picked, and you can start working on it, right? So the process of choosing one at the end of the day is very simple if you're very good at analyzing what's exactly required, what are the future trends, and how can you go on to solve the current problems that you might have had, right? Now, working on these, as I told you, it's not as easy as it sounds, but at the end of the day, if you're very good at evaluating project requirements and knowing what's required at hand, you can figure out a model and you can start implementing it. And having these models, in my opinion, is what gives wings to the domain of cloud computing, right? Again, it's flying across all the charts. Everyone around you is trying to use one form of cloud computing or another, and when that is the case, you have to understand why is cloud computing soaring so high. And in my opinion, these services are the reason for that, right? So let's quickly take a look at what you get to do and what IaaS, or infrastructure as a service, is. Now, infrastructure as a service, wherein you want a service, but as a service you're getting a complete infrastructure. Someone is saying, hey, here is a building for you to move in and you can start working. You don't have to take care about actually constructing the building, buying a land, buying plot for it, planning everything out, constructing a building. All of that is not there. Someone does it for you. The building is ready for you to move in and start using. Similarly, in infrastructure as a service, it's provision of cloud computing resources over the cloud. And here the cloud provider himself or herself, in this case it's people like DigitalOcean, AWS, Azure, GCP, all these guys. They'll say, hey, we'll take up some of the load for you, we'll do some of the heavy lifting so that you don't have to worry about a lot of things, and you definitely can go on to work on things such as logic or actually building your application. So what the provider supplies is things like infrastructure in terms of storage, in terms of networking, in terms of hardware, and lot more. IaaS is considered to be very, very popular, and it is portrayed to show a growth of around 40% in the year 2021 alone. Even though right now it might not be the most popular model out there, but I definitely think you guys should take a look at understanding IaaS seriously, right? When I say IaaS, it's basically IaaS, or infrastructure as a service, right? So this is very important for you guys to understand. In terms of infrastructure as a service, what it is that you'll have to manage and what is it that the cloud manages, right? Take a look at on the left side what you manage. Here you'll actually be working on your applications. You'll be taking care of all of your data that's required for your applications, all the runtimes. When I say a runtime, maybe you want to run Python code on the cloud, right? So you require a runtime for Python to work. You require the interpreter for it. And when you have to run all of these, let's say in a Windows operating system, you're going to require the operating system to manage, right? So you have the flexibility to say, hey, I want this operating system, I want to run these many runtimes on it. And of course, since it's your own application, you cannot have the cloud computing guy maintain your give you data to use for your application. You yourself must have your application, and you yourself must have the data that supports and helps your application work. This is what you manage in IaaS. But what does the cloud computing platform manage? Well, they are providing you servers for you to use. They are providing you storage methodology. They say, hey, we'll give you 30 terabytes worth of storage for you to run this application or something like that, right? So everything from servers, storage, authentication protocols, networking, creating a bridge to ensure that those servers talk to your applications, and everything, even including the concepts of virtualization, is what they will manage. So you will have to configure things on this side, on the right side of things, but at the end of the day, you will never have to set all of these things up from scratch, right? So this is IaaS. And when you take a look at the next thing, which is platform as a service, which is PaaS, as it's also called, again, here is where you're not getting an infrastructure as a service, but you're getting one platform as a service. Think of it as a part of the infrastructure, right? When people tell you, hey, you have an apartment building and it's already constructed and ready, and if you're just going to pick that up, that's IaaS, that's infrastructure as a service. With respect to platform as a service, people will say, hey, there's an entire apartment building ready, and we can let you have access to the third floor. Whatever happens in the third floor, it's yours, right? So you have one tiny platform in an entire infrastructure for you to use. Here, the similar analogy applies, wherein they are providing you certain resources, just like IaaS. They're providing you a couple of resources through which you can manage your applications, you can manage your portfolio, whatever it is that you're trying to run. You can have multiple frameworks, multiple languages, and knowing that there are certain things, knowing that, hey, someone is providing an entire platform for me to use, you as a developer will not have to break your head about all of these things, which eventually would have taken your time and your resource, right? With this, you can can actually sit and work on actually solving the problem. If you're writing an application, think about it. Why are you writing the application? Someone has a problem, your client, your manager, your company, someone has a problem, and you're trying to solve that problem using your application, right? So you will have more time to focus on actually solving it and making it better, rather than figuring out how things work, or how all these mundane things which tend to just keep the boat afloat, right? Things such as AWS EBS basically stands for Elastic Beanstalk. We have the Google App Engine, we have Apache Stratos, we have so many of these individual entities that are considered to be very good PaaS offerings in today's world, right? PaaS is something which is very good, even though the analogy where I told you saying, hey, someone would just give you a tiny part of an apartment building rather than the entire building. You have to understand that when they are giving you a tiny part, everything else that's required to run that entire building is managed by them. All you have to do is take care of your application. All you have to do is take care of your data. And of course, they cannot do this for you. Again, it's your application, it's your data. But once you figure out saying, hey, if I just have to concentrate on my application, if I just have to make sure that I provide data to my application, you have reduced all this load. You don't have to worry about servers. You don't have to worry about operating systems. You don't have to worry about setting up runtimes, breaking your head about networking, breaking your head about storage. You don't have to set up any of these from scratch, because that is what the provider there is doing for you. Of course, you might have to configure and you have to tweak a little bit of things to make sure your application talks to that service at the end of the day, but you don't have to buy any of that, right? So that apartment example, the building example that I gave you, I hope it's slightly more clear now, understanding what it is that you'll have to manage in the case of IaaS and in the case of PaaS as well. Great, that's platform as a service. Now, what is software as a service? Software as a service is basically a concept through which you can have softwares, again, which are nothing but applications, and these can be hosted on a cloud computing platforms. As a user, the user should not be concerned about what happens in terms of software upgrades, what happens in terms of hardware updates, and all of that, right? The biggest advantage of software as a service is that you're getting an entire software through which you can work, so it doesn't require any sort of installation of any applications on your actually already existing infrastructure. You have something that's already working, and once you try to use SaaS, all someone's saying is, hey, we are giving you an entire software. You don't have to do anything. You don't have to mess with your own architecture to make it work, and you just have to use you'll get to use all the features of our software, and you can use it as a service. Think about all these Google applications. Think about Gmail, think about Google Photos, think about Google Drive, think about Dropbox, think about a CRM such as Salesforce as well, right? So all of these work on a software as a service model, because they're just giving you one software that's an entire service that they're providing, and you at the end of the day have the capability to basically work on a lot of different things. And knowing that having an entire software wherein you might not have to mess with your existing infrastructure is critical, right? So here, think about Google Photos, think about Google Drive. All you do is you move your data around, right? So everything from their own applications, their server, storage, runtime, virtualization, OS, networking, data, everything is managed by them. All you do is you move your photo to Google Cloud. But do you actually have to be concerned about where you're storing the data in the Google Cloud? No, it can be anywhere. Right now, I am in India right now, and it doesn't mean that as soon as I move something to Google Drive, the photo gets stored in the Indian server. For all that I know, it might get stored in a server. It might get stored in the Google server that's in Dubai, that's somewhere else on the other part of the world, like in the United States of America or something like that, right? Think about it. You don't have to break your head even on the levels of data, even on the levels of application, because if you're using something like Salesforce, you can use their own software, their own platform to create everything that you require. That you're seeing that moving from IaaS to PaaS and now to SaaS, which is software as a service, the cloud is doing more and more and more, right? When it is doing a lot more, it is taking off every burden that you see on your screen right now. Even though I say it as a burden, because at the end of the day, you're going to require a ton of people to handle servers, maintain it. You're going to require a ton of people to work on storage. You're going to require a ton of people to work on networking, virtualization, operating systems, all of these things, right? So you have to keep all of this in mind, especially with respect to SaaS. So we can come to a section wherein we can discuss which of these is the most popular model. We spoke about IaaS, PaaS, and SaaS, IaaS, PaaS, and SaaS. You might be wondering, hey, so in today's world, which is the most popular service model that we have out there? Well, when you're talking about the most popular service model, you really have to understand who it is for, because IaaS, the network professionals are going to be the ones who are considerate, who will be using IaaS a lot, because they get to have access to those many things, right? With respect to IaaS, the cloud manages some things and the users still have a lot of things to maintain. So network professionals prefer IaaS. And when it comes to PaaS, people who say, hey, I only want to take care of my data, I only want to take care of my application, rest I really don't want to be bothered about, I can offload all of that to someone else. In that case, PaaS is useful. But let's just say you're not a developer, you're not a network professional, you want to use cloud computing platforms, but you don't want to have any sort of technical knowledge. Using Google Drive, you don't require any sort of coding experience, right? You open Google Drive, you log in, you just move your photo, you click it and drag it on your mouse. It's as easy as that, and just put it in their platform. Similarly for Salesforce, of course, you require a ton of training to work on Salesforce itself, but at the end of the day, you don't have to think about how Salesforce was built, or you don't have to sit and code about Salesforce to just learn about Salesforce or something like that, right? The analogy is similar here. If you're an end user who just says, hey, I want your entire software as a platform in itself, and I just want to start using that, SaaS is meant for end users. But in today's world, when we talk about the enterprise world, when we talk about what these big guns, what are the Fortune 500 companies using and what they prefer in today's world, you have to understand that platform as a service gives you the best of both abilities, right? It brings you a lot of advantages of IaaS, and it also gives you the flexibility of SaaS. That is the reason 35% of the entire workload that you would see on the cloud computing platforms in today's world is basically people using platform as a service, because this is the most popular one. And at the end of the day, it doesn't mean IaaS doesn't work well, or it doesn't mean SaaS doesn't work well. Depending on what it is that requires usage, depending on what proficiency, what your application is meant to do, or what level of flexibility you require, this is how the trend goes, right? But of course, as we're seeing, people do prefer PaaS over a lot of these things, but you will see that even SaaS and IaaS are quite popular there as well, right? So to give you a quick understanding, to quickly brush up on all of these things that we just discussed right now, think of the case of making, think of the case that you just want to eat some yummy biryani, right? Biryani is a very famous Indian dish. Now, when you take a look at biryani, if you are trying to have an on-premise server, it's like you saying, hey, I'm going to do all the shopping for all the materials which are required to cook biryani. I'm going to do it myself at home. I'm going to prepare it. I'm going to cook it. I'm going to eat it. I am done. Everything at home. That's similar to having an on-premise server. Now, with respect to infrastructure as a service, basically all you're trying to do is you're taking ready to cook biryani sets. You know that you'll find those packets on your supermarkets and all of that, and those kits will give you certain things to get started with the biryani itself. But you should still come home, you have to still cook it, you have to maybe mix the masala and do something a little bit. You're doing only a little amount of work rather than everything, right? And eventually you still get to eat biryani, right? Now think about PaaS. Platform as a service is basically you guys saying, hey, I'm going to call Zomato, Swiggy, or any of these popular food delivery apps like DoorDash, and if you guys are watching this from the US or something, where someone has already cooked the biryani for you and your job is to just sit and eat it. Your goal, in fact, is to just eat biryani. How you eat biryani is very important, right? You either cook it from scratch, you just bring a ready-to-eat kit, you do some of the work, or you have someone else do it completely for you and you would just sit and eat it. That is PaaS. Now thinking about SaaS, software as an entire service is basically you just walking into your favorite restaurant and you just wanting to sit there, eat biryani, and you're done. Your goal is met. So you're just moving into your favorite restaurant, you're using on the lines their software to actually sit there, make sure your goal is met, and you eventually come out of that application, come out of that restaurant, right? Now talking about all of this, biryani definitely has made me a little more hungrier, if I can be honest with you, but I really hope that understanding cloud computing services this way will actually help you have complete clarity on what it is that we just spoke about all this while, right? Now, coming to talk about infrastructure as a service in slightly more detail than what we just did, as you already saw, IaaS is very popular. You get to have access to a lot of different things, and in this type of cloud computing environment, you get access to everything from virtualization to servers to networking and everything. And as I just told you, it will require a bit of tweaking and tuning to get to work. Right now, think about the biryani example that I gave you with respect to IaaS. It's you take ready to cook biryani and you eventually start preparing it, right? Of course, as I told you, an entire infrastructure is provided to you as what you would use, and eventually understanding that, hey, I can have an entire infrastructure and I can run any sort of applications or service that I require, and knowing that IaaS is very popular in today's world, especially for things such as rapid prototyping and deployment. Rapid prototyping is a very simple concept. Let's just say that you're a person who's just writing a couple of applications and you want to quickly take it from prototype to production, right? That is nothing but rapid prototyping, where there are many applications that you'll be building and you want to check if this works, that feature works, this application works, this tool works or not works, right? So you're just quickly making some sort of assessments and you're having to quickly go from prototype to end product. When that is your requirement, IaaS is something that you should be considering, right? Now, with respect to IaaS, you might be saying, hey, so what are some of these services that we get to use? As I told you, the provider will take care of a lot of components which are required, and some of the infrastructure is usually actually found on an on-premise center, but at the end of the day, you really don't have to break your head about a lot of things, as we just checked out, right? A wide range of services are provided. Ladies and gentlemen, as I told you, it's an understatement when I told you that it'll save you a lot of time and effort, because at the end of the day, as a developer, your job is to sit and develop something, maybe write code or something like that. With respect to having infrastructure as a service, your 100% focus will remain on the task at hand. You actually solving the problem, you actually writing that piece of code in an environment that is meant for it, and knowing that, hey, this will work now for 10 users, maybe a couple of months from now, if 10 million users want to use it, it will still work, and it is not your headache to figure out how to make it work for so many people. If your application, if your code is robust enough, of course, your code doesn't really change for a lot of these cases, but if that is the case, yes, it will have some sort of an effect on it. But if your application is secure, knowing that your code is secure and you can scale it as much as you want, and you don't have to be bothered about how it gets done, knowing that you'll have to buy a new server, all of these things is not your headache anymore. If you're a developer, your focus is on core development, right? So with respect to IaaS, we saw all the services, we saw what the cloud manages, and we saw what you manage. But one thing you have to understand is that with respect to security methodologies, these guys are also providing you with respect to a couple of protocols, that giving you authentication methodologies, and they say, hey, we'll give you these services through our infrastructure that you can go on to use. Now, as I told you, data backups, right? Backing up data, be it photos, videos, or whatever it is, any important office documents or something like that, you can back it up. They're giving you services, they're giving you apps which are ready-made for this, and you can actually leverage these apps. And at the end of the day, replication, when we talk about replication in the world of cloud computing, that is a good thing. I'll tell you why. In today's world, let's just say you have data stored in one server. Let's just say due to natural calamities, the server just failed, right? There was an earthquake and the server got messed up. Your data is gone. But if your replication, if you've set up replication methodologies, duplication is a good thing in cloud computing, because for a fact, if something happens to your data in that server, there will be another server which is sitting at the backup saying, hey, if something happens to this guy, I'm here to pick up all your data, right? So your data gets split and stored into two different entities at the same time. If one goes down, great, nothing bothers you. There's another server which will go up right the moment this one goes down, and it still gets to do all the heavy lifting for you. Knowing that this feature is available is important, because if one server goes down, maybe your entire application or website crashes down. Maybe you lose a ton of sales because of the fact that people could not access your website because your server crashed or something, right? All of that, including a concept called load balancing. Now, load balancing is very important for a fact that let's just say you want to make use of 10 different computers and you've given them 10 different operations to do. How do you know that one of those computers is working at 100% capacity while the other one can be sitting at 5% usage, right? You need to balance the load amongst these many computers to ensure that each and every one of them have an equal amount of work, so that one is not strained to a point of failure or the other one is not just relaxing and not doing any of the work that's required, right? This kind of a balance, this kind of a fine balance, it is usually done automatically. You can have manual load balancing, you can have automatic load balancing in today's world as well. As and when the platform detects, as and when the infrastructure detects that, hey, this application is taking more resources, you can start saying that, hey, if this starts taking more resources, automatically start allocating it, so that your website won't crash. If your website is meant for 10 people and if the 11th guy comes over, it doesn't mean it has to crash. Your server is going to recognize that and it's going to provide more resources so that 11th guy can actually have access to it, right? So everything on the terms of load balancing, everything on the terms of even data logging and billing, right? Of course, billing is a critical service. As I told you, with respect to pay as you go, you'll only have to pay for how much ever you go on to use. And with respect to IaaS, that is a huge advantage. Right? Now, talking about advantages themselves, one important thing you have to understand about IaaS is that these IaaS users will have access to work on complex levels of automation, and you really don't have to spend a lot of time to do that because there is already an infrastructure that is set up and ready for you guys to use. All you have to do is think about actually solving the problem. Right? Now, think about orchestration. Think about how you will go on to assess and analyze these tasks and actually go on to split up the load between multiple entities, multiple teams, people, or whatever it is. Now you'll have more support to do it. You can do it in a more robust and a good manner, through which, even though you will know that, hey, even though I have 10 active machines running and maybe I only want to use 8, you can still have those 2 machines as backup. So orchestrating for certain critical tasks, saying that, hey, no matter what, this application should not crash, should not go down, there should be no downtime, right? Doing that, and just that, saying that, I want 0 downtime on my applications, do everything you can do to make sure that happens, is the biggest advantages for enterprise grade companies, right? Because for them it's a big deal. You might have seen the news recently or sometime, right? There is usually, it rarely happens, but there are certain times, like even a company like Google, one of its services shuts down, Gmail stops working for a while, maybe something in Google stops working, right? People around the world flip, their stock value starts coming down. People start selling shares from the company just because of the fact that they had certain downtime, because that downtime at the end of the day would have cost those companies a lot of money. Having a downtime of 10 minutes costs millions and millions of dollars for the clients who are using that platform, right? Now I'm giving you a hypothetical example, but yes, it happens in the real world. So knowing that with respect to IaaS, you're covered in all these aspects, knowing that you have greater modularity in terms of how you can work on your app, knowing that you can put all your focus on solving the problem, is something which is very, very important, right? And this ability to actually automatically load balance will just keep the performance of your application, performance of those machines at its toe, to make sure that everything is working in an optimum manner, and at the end of the day you're getting the advantage of availability as well. It's not like the 11th guy starts browsing on your website crashes. If the 11th guy tries to log into your website, your server realizes that and it quickly assigns whatever load that this person brings, it quickly assigns it to maybe a new machine, new service or something, to a point where the user will not feel a thing. The user will not know that something happened in the backend as complicated as this. This ability is the biggest flex and the advantage for IaaS, in my opinion, right? So let's quickly use this learning to understand how does IaaS work at the end of the day. The working on the whole is a very simple concept, but at the end of the day, it is very, very powerful, right? First of all, the resources get accessed by the users using internet or a WAN. As you might already know it, to use Google Cloud Platform, to use AWS or to use Azure, you have to have an internet connection at home, right? It doesn't mean that you have to have like like 1 Gbps, 300 Mbps or something like that, even with a decent enough internet connection, you can have access to the fastest servers in the entire world today, and it is possible for you to do so. So what do users do? Users basically log into this platform, this service, and eventually they start working, they start installing all the remaining dependencies that's required for their application stack, right? Now let's just say I have a machine learning solution that I want to use, or I want to deploy on the AWS platform. What AWS do is they say, hey, we'll provide AWS SageMaker for you to use, and we're giving you the entire AWS infrastructure for you to sit and use. But that doesn't mean everything is ready for my ML my ML app. Not really, right? I have to sit and write the ML code myself. That is where my concentration is. That is where my focus is. And after I write this ML code, then I take it to the infrastructure. Or in fact, I can sit and write it on the infrastructure itself. And I say, hey, now I'm going to need your tools. Now I'm going to need the support of your infrastructure to run this piece of code. That at the end of the day is how IaaS works as well, right? So think about the example that's shown on your screen right now. Users can actually log into any platform that they want. They can set up multiple virtual machines for multiple tasks. They can create storage buckets wherein they want to put certain types of data in. They can track all the costs about how much pay-as-you-go policy. At the end of the day, you still have to pay as you go, right? So maybe you just used that particular VM. You use these many resources for these many hours. You use that service, this tool, this resource or something like that. So for that, you'll have to still have a way to detailedly track, have the ability to track all of that to a good amount of detail is what you'll get access to as well. And of course, balancing the workloads and doing a lot more. IaaS is on the whole, it's so improved these days that I have to say it is very simple, but do not be fooled by its simplicity, because at the end of the day, it's extremely powerful in today's world, right? So an important thing you have to know about IaaS is the fact that in terms of any form of service, right, it requires platform support. No matter how powerful your ML machine learning model is, at the end of the day, you require the support from the platform to actually go on to deploy it. Now, AWS, Azure, GCP, IBM Cloud, Red Hat, all of these are like super good examples of IaaS providers today. And not just that, it is also a fact that you can deploy anything to a private cloud, and eventually you don't have to go to these guys compulsorily to use IaaS. If you have a private cloud, you can set it up such that it works in an IaaS manner, and you can be your own provider of IaaS as well. Let's just say you have one server for, let's say, one building or something, and you can create infrastructure as a service, and you can provide that infrastructure to the people in the building, right? So that's a private cloud, yet you have the flexibility of IaaS. And not just IaaS, you can have PaaS, you can have SaaS, you can work on any sort of model as is, right? So it's not just IaaS, but it is important for you to understand that yes, that can be done. And this is the primary reason why we had to discuss the entire concept of public clouds, private clouds, and community clouds. Because if you're not clear with that, when you start understanding all of these, you can be like, what's a private cloud, or why, or how can we even use IaaS on private cloud? Well, now you know both, and you have the answer to how IaaS works as well. So quickly brushing up and revising on some of these advantages of IaaS, we already checked out a lot of them, but the biggest advantage is for a fact that you can set up at a lightning pace, and you can start working on these applications. You can start deploying these applications right away, and you don't have to break a sweat about a lot of things which eventually the cloud will manage for you. That's important. The second thing, we'll have to revisit this point, because this point is the reason why we have cloud computing at its popularity today, is for the fact that it's extremely cost effective. You really do not have to spend, a lot of money on hardware. You can just rather have one laptop or one good computer rather than spending thousands and thousands of dollars on servers, thousands of dollars in actually having a person maintain those servers, cool it, pay electricity for it, ensure that it is safe. None of your headache. All of that is taken care by someone else, right? So in terms of maintainability of servers, not just servers, in terms of these services, the infrastructure load. Now you have an application where you would have told AWS saying, hey, I need these many resources. Provision of those resources and how it's provided, from where it is provided, or which part of the world is using what servers to give you access to these resources. not your headache, right? The platform is responsible for all of that. All your task is to do is sit and actually solve the application, sit and actually solve the problem for which you approach the cloud computing platform to say, hey, I want my application to be deployed on your platform. You will be working on your core task at hand here, right? So IaaS is actually extremely popular for rapid prototyping, as I would have told you. So anything in terms of experimental, anything in terms of temporary workloads, wherein you're a company who says, hey, I just want to try out if this works or not before investing heavily on hardware. Let's just say you've made up your mind that you want an on-premise network, but you want to try it out. You want to see if it works. IaaS is great for that. You can actually you can reach out to platforms, you can start picking up their services, and you can host deploy models, check if everything works. You can tweak it, test it, make sure that it's 100% ready, and at the end of the day, once it's ready for production, everything works, and you have confidence that this, when it's moved to any server, it will work really well. Move everything back from IaaS to your on-prem services, and eventually you can have the security of your on-prem services. You can make sure, of course, right, on-premise has its own advantages. Even though it's slightly annoying to invest a ton of money to get it done, people will have on-premise. Hybrid clouds are a thing, the most popular thing, in fact. And at the end of the day, all these businesses, when they go to IaaS, either they go for two things. One is rapid prototyping, kind of a state of mind, or they say, hey, we will commit really long term for you guys, and no matter what, we'll just be using your infrastructure maybe 1, 2, 3 years from now, and they will get to reap the entire benefits of IaaS. And in that situation as well, they still can have private cloud, they still can have on-prem and use the best of its abilities, right? So that is the super amount of, this is a huge amount of advantages, I just want to say, for IaaS. Now, of course, with those advantages comes slight disadvantages of IaaS, and at the end of the day, usually the most important thing that people tend to skip is when I keep saying pay as you go, right? You still have to pay for those resources. And in IaaS, it's a common thing that you would have think, hey, it would cost me so and so. It would cost me XYZ dollars. But at the end of the day, you'll be surprised to see that it is 2 times what you would have thought of, right? Especially starters, beginners, and people who have just moved into the cloud computing platform, they will tend to undermine the amount that it will cost them. And at the end, that will end up hurting them, right? It's not their fault. It's not the platform's fault, but when you are using a service such as this for the first time, it can get confusing, and you can tend to pay a lot more than what you might have initially expected. Now, one more thing about performance metrics and understanding the infrastructure configuration, right? How it is made. All of that, it's a good thing that you don't have to be bothered about, but at the end of the day, it is not visible to users if that is required for you. If you say, hey, if I'm using your infrastructure, I want to know each and everything about your infrastructure, whether it is useful or useless to me, I don't mind. I want to know everything, because that will tell me that it is more secure, more safe, or whatever it is you're looking after, right? In many cases, this kind of transparency it's never possible. It's just a deal done on trust, right? If you say, I want to understand everything there is to know about AWS, regardless of whether I use it or not, it's not possible. That kind of transparency will be difficult in terms of providing it to you, first of all, in terms of their own competency. And at the end of the day, monitoring tasks, managing tasks, understanding ways of how, those things work on its own, how it works with your application, right? You don't need to break your head about all of that. But if you're a person who says, hey, no, I really want that kind of flexibility, well, IaaS might not be, for you. As I told you, if you're a person who says, long term, I want to start using IaaS, absolutely beautiful. If you're a person who says, hey, I want to try short time prototyping, rapid prototyping is my thing to do, and I want to use the power of these platforms, well, beautiful. You can still do it, right? So regardless of everywhere around the world, regardless of the stats we actually discussed, it is my personal opinion that IaaS is actually getting more and more popular today, because with respect to platform as a service, you get certain tools. You get AWS, EBS, Elastic Beanstalk, or something like that. But with respect to IaaS, you get the entire infrastructure of AWS through which you can sit and work, right? With SaaS, it's even better. It's like walking into your favorite restaurant to eat biryani. No headache of thinking about cooking your biryani, no headache of actually preparing it, no headache of doing your dishes, nothing like that. You walk in, eat, walk out. Done, right? How simple is that? So ladies and gentlemen, you have to understand that there are certain disadvantages with respect to IaaS, but in my opinion, the advantages advantages outweigh any of these disadvantages, right? And since you're using IaaS, another disadvantage we have to talk about is for a fact that you're at the mercy of the availability of the platform. If AWS, as I told you, it rarely happens, but if a couple of their servers go down, your application, if you are not set for replication, if you're not set for redundancy, it might happen for a fact that something might happen to that server and there, someone just crashed into their workloads or something, and your application can still go down. You might say, hey, I have a backup server. What if the backup also fails? So at the end of the day, in reality, it might never happen. But when you say never, there is a short amount of probability that it can happen. So you have to be prepared for that as well, right? No one expects that your data is stored in 3 servers and the entire 3 data center crashes. Never has happened, never will happen in my opinion. But at the end of the day, there is a possibility. There is, let's just say there is 1%, 10% probability that it can happen. And when that happens, it is you as a client who has to say, hey, there's nothing I can do about it. You just have to sit and watch your application have a downtime or something like that. Of course, there's many things, where you can get to make up for all of that. Another story, but that in that moment, your application has a small amount of downtime, which you'll have to take care of, right? It doesn't happen as I told you, but when it does, you're at the mercy of the platform here. So guys, with this, we have come to the end of the course. We started this out by discussing everything from understanding what cloud computing is, why is it the future, why should we even consider cloud computing, right? Once we understood all of that, we took a look at how the domain of cloud computing works. We realized what middleware is. We understood backend, we understood front end and all of that. Once we figured out how the cloud computing platforms work, you guys were very, very interested to understand the types of various, cloud deployments that we have: public cloud, private cloud, hybrid, community, all of these clouds, right? So we ensure to take a look at each and every one of them, understand them, and also take a look at the advantages and disadvantages of those types of deployments. Because after we understood those deployments, we took a look at the various service models we have on the lines of infrastructure as a service, platform as a service, and software as a service as well, right? So we broke it down into very simple terms. We understood what each of it does, what are the advantages, what do you get to manage, what does the platform provider get to manage, and all of that. And after that, we took a small deep dive right into understanding IaaS, or infrastructure as a service. We took a look at what it is, how it works, and we understood the process of IaaS. We understood where it is used, where it is best fit, and of course how you can use it as well. We took a look at some of the very important advantages, disadvantages. We had small comparisons here and there everywhere. We made sure to take a look at everything you require to understand cloud models, and of course IaaS to a good amount of depth as well, right? So guys, with this, you've come to the end of this course. Thank you so much for watching. Do check out more courses we have on here. Thank you so much for watching. My name is Anirudra. I'll see you on the next one. Cheers.
If you haven't subscribed to our channel yet, I want to request you to hit the subscribe button and turn on the notification bell. This is done to make sure you do not miss out on any of the new updates or video releases from Great Learning. And of course, guys, if you enjoy this video, show us some love and do like this video. Knowledge increases by sharing, right? So make sure you share this video with your friends, colleague, and everyone who can make use of it. And at the end of it, make sure to comment on the video if you have any queries or any suggestions, and I'll be more than happy to respond to all of your comments.